All right. Everyone's looking up here? No headphones? Right? Right? All right. So check it out. If you didn't finish map first. Don't worry about what we're doing. Make sure you do that first. Today we're talking about Pythagorean Theorem. Should be a blast from the past. We'll have a quiz next week, but let's do this warm up. If you were absent any day this week, put absent, right? But square root of 54. Please remember, when we do a factor tree, we're doing this. We always start with 2. Does 2 go into 54? Or can 54 be divided by 2 to get a whole number? The answer is yes. 2 times 27 is 54. Okay. Now, this is an odd number, so 2 does not go into it. Let's try 3. Does 3 go into 27? 27 divided by 3 is 9, so yes, 3 times 9. And let's try 3 again. 9 is 3 times 3, so yes, it works. You have to be able to do a factor tree, and then second of all, you have to circle your pairs. I have one pair of 3. Radical answer, the couple goes out to the left. The loners, 2 times 3, stays inside on the right. Okay, now I'm passing out your notes for today. Quick one-sided notes. All right. Now, how many of y'all have done Pythagorean theorem before? I see a hand. The rest of y'all haven't? Yeah? Anyone want to raise your hand? Too cool, raise your hand. All right. Well, yeah, Pythagorean theorem. Hopefully you've done it before. Whether you have or have not, I'm going to make sure you understand it. But also, we are incorporating literally what we just did, simplifying radicals, with Pythagorean theorem. Okay, they go hand in hand. And this is something you're going to see in the future in geometry. So we're trying to prepare you for when you see it, you'll be good. So here we go. All right. All right. Now, Pythagorean theorem. A squared plus b squared equals c squared. Maybe you heard of it before. But when would we ever need to use this? That's what we're going to answer right now. Notice the little picture off to the left. Whenever you have a triangle with this little special symbol, what does this mean right here? Do y'all know? What kind of triangle is that? How many degrees does that little square mean? 90. It's a right angle, so it's a right triangle. Okay. Now, so to answer these blanks here, it's used to find the missing length of a right triangle. Cool. Now you got to know the names or the titles of these specific legs. A and B are called. The answer is legs. So A and B. Notice A and B are next to the 90-degree angle. Like imagine a stick figure with a 90-degree angle when he's walking. Actually, really awesome. Anyways, but the legs make 90 degrees. Okay, that's the visual you need. Okay, so A and B are called legs. So this is where people mess up. Which one is C? C is across from 90. It's called the hypotenuse. It's across from the 90-degree angle. So for any right triangle, the Pythagorean theorem is a squared plus b squared equals c squared. Well, let's get to it. Number one, is it a right triangle? Yes, it is. I see a right angle, right? So this is what I'm going to do on these notes. I suggest you do it until you for sure know this stuff, okay? But you have to know which side is A, which side is B, and which side is C. So this is your process. Here's 90, right? I'm going to outline 90. Next to 90 is going to be A and B. Cool? Then I'm going to draw an arrow across from 90, and that's going to be my C. Do you need to write that every time? Not if you can identify it mentally, but at least for now, these are the training wheels, okay? So A and B are next to 90, C is across from 90. Let's write down that Pythagorean theorem, all right? So A squared plus B squared equals C squared. So A, we have right here, is 8, B is 13, C is X. So 8 squared plus 13 squared equals X squared. Now you are allowed to use Desmos, okay? In fact, let's read these instructions because there's two different ways you might see the answer, okay? Find the missing side of each right triangle below using the Pythagorean theorem. Round. Round your answer to the nearest hundredth. What does that mean? Your answer is a decimal, okay? So when you see round, you're not going to do the factor tree like our warm-up. You're just going to use Desmos, okay? And here's what I mean. 8 squared plus 13 squared. You can do it separate, like 8 squared, 13 squared, and add them up. Or you could just do it in one step, 8 squared plus 13 squared. Either way, you're going to get 233, okay? So 233 equals x squared. Now, is x by itself? Almost. There's a squared here. We talked about this last Thursday, okay? But when you're trying to get rid of a square, the opposite of squaring is square root. The opposite of square is square root. So if I want to get x by itself, to get rid of this square, I'm going to square root this side and square root this side, both sides, right? My square and my square root cancel out. Now, in theory, maybe you could do a factor tree on that, but the instructions say do not. The instructions say, what's the decimal? So that's what I'm going to go over here and figure out. What is the square root of 233? I got 15.264, blah, 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 right? Now, it says to round to the nearest hundredth. Don't know what a hundredth is? You got tenths, then you got hundredths, then you got thousands, okay? So here's the deal. To round to the nearest hundredth, you see where the 6 is? You're going to look to the right of it, and if it's 4 or below, it's going to stay the same. If it's 5 or above, it's going to round up. So does this stay the same or round up? Stay the same. 15.26 is our answer. That's it. Cool. Could you do that? I hope so. Look at the next one, number 2. There's no variable, there's no letter, so I'm going to put a letter here. I'm going to use a different one than number 1. Let's go ahead and use the letter y, the variable y. And once again, I need to know A, B, and C. I know A and B are legs next to 90. So here's my 90. So this is A and B. Across from 90 is my C, right? So let's write Pythagorean theorem. A squared plus B squared equals C squared. A is y, B is 3, C is 4. So that's y squared plus 3 squared equals 4 squared. Listen to me say this. The most common error is people always want to put the two numbers as A and B. I want you to notice 4 is not a leg. 4 cannot be the A value right here. It's not 3 squared plus 4 squared equals y squared, okay? You have to look at which one are the legs, which one's the hypotenuse. So number 1, we were missing the hypotenuse, the longest side. But on number 2, we know the hypotenuse is 4. We're missing a leg. Sorry, usually I'm standing up. We're missing a leg. Well, let's do some math. So 3 squared is 3 times 3. What do we get? 9. All right, and then 4 squared is 4 times 4, which is 16. Okay, so y'all are able to square numbers, hopefully. If not mentally, you can use Desmos. But this, we're not going to add up 9 and 16. They're on different sides of the equal sign. Okay, we need to remember last week, solving for x or solving for y. If I'm going to solve for y, I need to get rid of this loner. The opposite of plus 9 is minus 9. So if you're missing a leg, you're going to end up subtracting. All right, so y squared equals 16 minus 9 is 5. And just like last time, how do I get rid of a square? I square root. Square root. So square root of 5, here we go. Square root of 5. My bad. Did I say 5? Did I say 5? I didn't mean to say 5. My bad. All right, so look, 16 minus 9 is 7. My bad. So square root of 7 is 2.64, and then the next number is a 5. Does that 5 make this 4 round up? If it's 5 or greater, yes, we'll round up. So this is 2.65 when you round. 2.65. Now, hopefully that's just like a review. Hopefully you've seen that in middle school. Hopefully that's old news, right? The next two, very important that you tie together Pythagorean and what we've been doing with simplifying radicals. We're marrying these two ideas today, okay? Are we good on 1 and 2? Look at number 3. Find the missing side of each right triangle below using Pythagorean theorem. Leave your answer in simplified radical form. What is that, Mr. G? Well, that's the factor tree stuff that we've been doing, right? Whenever you see simplified radical form, you're going to do a factor tree, not rounding a decimal. Here we go. Right triangle. Where's my legs? I got A, I got B, and across from 90 is C. A squared plus B squared equals C squared. A is 4, B is 6. 4 squared plus 6 squared equals x squared. What is 4 squared plus 6 squared? Okay, I can do it in one step like that. I got 52. So 52 equals x squared. And then once again, to get rid of a square, we square root. Square root. Now, do not type square root of 52 in the calculator. It tells us we need to find it in simplified radical form. So we are going to factor tree, just like our warm-up. Does 52 divide by 2? Since it's even, the answer is yes. That's 2 times 26. 26 is even, so that's going to be 2 times 13. And 13 is prime. So what do? Circle my pairs. And I get pair of 2, loner 13. Couple goes out, loner stays in. I get x is 2 square root of 13. Cool. So we took Pythagorean stuff we knew or just learned and combined it with simplifying radicals. Number 4, missing side. I'm going to put a y there. You could put x if you want to, whatever. Okay, don't matter. Here's 90. So I have A, B, and across from 90 is C. So once again, we're going to do Pythagorean theorem. A squared plus B squared equals C squared. A is 5, B is y. 5 squared plus y squared equals 11 squared. Can we square 5? Can we square 11? I believe so. 5 squared, 5 times 5 is 25, plus y squared. And what's 11 squared? 11 times 11 is 121. So, if I'm trying to solve for y, first I got to get rid of, again, if I have a missing leg, I have to subtract to get rid of this loner, positive 25. 121 minus 25. If you don't know what it is, just do it right here. 96. Okay. And then, how do I get rid of a square? Once again, square root. Square root. Do I type it in and get a decimal, or do I do a factor tree? Again, simple radical form is factor tree. Let's do it. I'm going to do this a little faster. 96 is even, so 2 times what? 48? 48 is even. 2 times 24? 24 is even. 2 times 12? 12 is even. 2 times 6? 6 is even. 2 times 3. Sheesh, that's a lot of 2's, right? How many pairs? 1 pair of 2, 2 pair of 2, and then 2 loners. So y equals square root. The 2 pairs multiplied, 2 times 2 is 4 on the outside. The 2 loners, 2 times 3 on the inside is 6. Okay, I'm going to pass out your assignment. I want you to be working on that. Any missing work you need to. Here we go.